Let's wait a few more minutes for everyone to join and then we'll start. All right, so I guess we'll just go ahead and get started. And thanks for coming to our sixth class. I think, yeah, this is our sixth class. And just a reminder, we have a total of 9 classes. And since this is the end of our week 2, we're gonna have 3 more classes next week, and then we're gonna be you guys are going to be ready to go, like pretty good at Java if you already were attending the previous 6 classes. And today we want to talk about some useful math library methods, some string methods, like quickly go over those. But before that, we want to kind of talk about while loops. So let me share my screen and then okay, let me share my screen. So I think you guys can you guys see my screen? Okay. Yeah. All right. I have the chat on this side. All right. So while loop is similar to for loops and for each loops because it allows us to loop through certain repeat a certain block of code until a condition is met. But the difference between while loops and for loops is that you can kind of categorize for loops and for each loops as a subcategory of while loops. So for loops are once you get to a certain number, you would just stop running your code. And for each loop is just once you get to the end of a list, you stop repeating that code. But for while loops, it's more general because you can ask it to meet any condition. So if any condition is met, then the code would stop running. And then you would keep running the code until that condition is met. So I'm going to do a live demo of while loops. So you want to go to your Eclipse project. And this is our work last time. So let's just save and remove that for now. And let's start a new project called while loops. So we're going to create a new Java project and call it while loops. And I recommend it if you follow along because it's good to like do some practice so that you fully understand what while loops are. And we don't want to create a module, so press don't create. Okay, and now you can see our while loops folder here on the left. So again, if you inside the source folder, if you create a class, and let's just call it main, and check this main method box as usual, because we want to have the main method inside of our main class. And then when you press finish, you're going to see your main class here. Okay, so now you have your main method and your main inside of your main class. We're going to be writing all of our code today inside of this main method. And I want to start talking about while loops with one simple example. So let's say we declare the int a equals 0. Okay, and what while loop does is it keeps running until a certain condition is met. So, and the syntax for while loop is you write the keyword while and then parentheses. Inside of the parentheses, you're going to write the condition that needs to be. Usually it's you want to write the condition that has to be true for the code to keep running, meaning that if this condition is false immediately after this condition is false, your code is going to stop running. So for this case, let's say we want to run this 10 times. So we're going to say while a is less than 10, and then we're going to print a. And now if we just do this, this code is going to be running forever because a is going to always stay at 0 and it's never going to be greater than 10. So this is going to be stuck in a loop that's going to run forever. So what we need to do here is say a equals a plus 1. And abbreviated version to write this is just a plus plus. This means that you're incrementing the variable a by 1 every time this loop runs. So when we run this, we're going to expect it to print all the variables from 0 to 9. Right. And the reason why this didn't print 10 was once we reach 9, it's going to add 1 to this value, and then it's 10. So it's no longer less than 10. Therefore, the condition inside of this while loop is never going to be run. Okay, and this is just one example of while loops. You can write any condition inside of here. So one example would be, let's say if we have a array, array int a equals, and let me delete my while loop. Okay, int a equals new int, and this int array has a length of 5. Or actually, I can do a array list integer a equals new array list integer. So I'm just creating an array list here, and we want to import this array list, java.util.arraylist. Now that we have our array list, what we want to do is use a while loop to delete all the values in our array list individually. So obviously we could just, if we want to do that, we could just do a.remove or a.remove. But if we want to delete all of them, we could just do a.clear. But since this time we want to demonstrate how while loops work, we're going to delete them one by one. Okay, so our strategy here would just be to delete the 0th element every single time, because if we delete the 0th element every time, so if the first time we delete the 0th element and the length becomes 4, and if the second time we delete the 0th element, the length becomes 3, and the third time we delete the 0th element, the length becomes 2, and so on until we reach a length of 0. Okay, so let's just say, let's add 5 elements to this. 1, a dot add 2, a dot add 3, a dot add 4, a dot add 5. So now that we have 5 elements, we're going to use a while loop to remove all of them. Okay, so while a dot size, this is a way that we use to access the size or the length of this array list. So while a dot size is greater than 0, we're gonna do a dot remove index is gonna be 0. Okay, And then let's see if we run this. Okay, so it runs successfully. And now at the end, if we print this a dot size, this should give us 0 because we have already removed all of our elements. Okay, it gave us 0. So our code works successfully. The code that would run till random number equals 6. You gotta run. Need a code that would run until a random number equals 6. Gotta run with the random. Oh, okay. Yeah, there's quite a lot of things you can do with while loops, and I'm just giving a few examples here. All that you need to remember here is all that you need to remember is you have to write the keyword while, and inside parentheses you can write your condition. So this condition is going to tell you whether or not your code is going to run the next time. So if this condition is true, this statement inside of the brackets is mic is out. That's okay. That's probably because my connection is unstable. Okay. Yeah, let me take a look because so all of you so try to let me see if so okay, so all of you have your mics and cameras turned off. Yeah, I think the bandwidth for Zoom is really small. That's probably the reason why we're having some trouble um with the mic. Can you hear me now? Can you hear me clearly now or uh okay. Yeah, it's periodic. So next time if you hear anything that's like if my mic is cut off again, then just let me know. And I'll repeat what I said. So like for while loops, you just need to remember to write while and then the condition and then whatever's repeated while that condition is true. There was a little bit. Okay. That's quite strange. Okay. So I guess I'll just continue and we'll talk about some really useful methods for Java. Okay, these are methods that are for primitive types and also strings. So let's start with useful methods for strings. Okay, we're gonna write all of our code inside of the same method here. So string methods. Okay, so the first one is the length method. Length. Now this would give you the length of a string. So let's say string s equals hello world. And so type in the chat what you think would get printed if you did s.length. It's really weird. Yeah, that's quite weird. I don't know why that is. So it would print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so it would print 11. If you run this, it's going to give you 11. So that's just what the length method does. It prints the length of a string. So that's pretty easy. And the next method is the, let's see, a concat. Okay, and the concat method, I think what it does was let's see how, I'm trying to kind of forgot what this method does, but concat. So let's say hello world. I think it removes the spaces of your method. Let's print this. System.out.println concat hello world, and then okay, right. So what this does is so it concatenates s plus or s plus hello world. The mic cut off. Oh, okay, it came back. Okay, so right, the concat is just equal to your basically adding the string s with hello world. Okay, so if you do these two things, it should give you the same, right? It gave you the same answer. Well, hello world, right? Give you the same answer. So concat is just the same thing as plus. So when you do plus in with strings, it's gonna add the two strings together. So that's what concat does. Okay, so these two are equivalent. And then equals, right? Equals is just used to compare two strings. So basically, if you say system.out.println s dot equals hello world. So now this is going to give you true because the string s is equal to hello world. So if you print this, it's going to give you true. So what this does is just compares two strings. So that's what the equal method does. The next one is the index of. Okay, the index of is just used to a s dot index of h, right? Okay, yeah, let me repeat that. So what the index of method does is it finds the first occurrence of a certain character within a string. So try to think about what would get printed if you do s dot index h. So type your answer in the chat. Yeah, it would get print. It would print 0 because h is the first index of hello world, right? It printed 0. Now, what do you think would get printed if you type a character that's not in the string? Say a, right? There's a never occur, like it's never in the string, so you can't find it anywhere in the string. What do you think would get printed if you type a? So think about what would get printed. Would it be an error? Would it be -1? What would it be? What would it be? Okay, so well, let's see. It printed -1. So that means that every time if we enter a number that's not in the string, we can just do, it'll just print -1. So that's one way for us to check whether or not a certain character is in a string, is just to see when we find the index of it, if it's equal to -1, then it means that it's not in the string. And if it's anything but -1, then that means that it is in the string. So we could use the if-else statement to do that. The next method is char at. So this is basically the opposite of index of. Index of is if you give it a character, it's going to give you the index of that character. And char at is if you give it an index, it's going to give you the character of the corresponding index. So let's say system.out.println char at, let's say 3. What would be printed if you write char at? So s.char at 3. Okay. So what do you think would get printed if you write s.char at 3? Yeah, it would print L, right? Because L is at the third index of hello world. Let's talk about substring. Substring is another method that you can use to find, it's just what it says, it's find a substring of a string. So if you want to say the string is hello world and you just want to print the hello part, what you got to do is give it a starting index and an ending index. And you have to remember for this, the ending index is not included. So the range would be the starting, and then the end would be an open bracket, meaning that it wouldn't be included. So for this case, hello world is index 0, 1, 2, 3, 4, and then you got to give it one more. You got to say 5. That way it's going to print hello. Okay, so let's say system.out.println s.substring 0 and give it 5, and then that's going to give you hello without the space, because you might think, well, the space is at index 5, but it doesn't include that index. So you always have to give it one more index than the index that you want. Okay, so that's the substring method. To uppercase and to lowercase just converts the entire string to lower and uppercase. So system.out.println s dot to uppercase. So this is pretty easy. And then let's copy this and do instead to lowercase. Okay, so see what it did here? It converted all the characters to uppercase and all the characters to lowercase. Okay, let's go over. So those are all the methods for strings. And for now, those are everything you need to know. And there's not that much more. And other ones are not quite as useful. That's why I didn't include them. Okay, so those are string methods. Now let's talk about some methods in the math library. So methods in the math library, we talked a little bit about this, I think during the second or third class, but we didn't cover all of them. So today we're going to cover all of them. So the first library methods. First method is abs. So what this does is it gives you the absolute value of whatever you enter. And this is fairly intuitive. So it's fairly easy to understand. It's just if you do math dot abs and then give it -1, that's going to give you +1. It printed 1. Okay, if you give it 1, so if you give it a positive 1, it's still going to give you 1 because the absolute value of number is its distance from 0. The second method is called max. Max. So this is max. What max does, it gives you the maximum of 2 integers. So let's say if you do math dot max and you give it 2 numbers, if you give it 4 and you give it 5, what do you think would get printed as a result? Is my mic cutting off again? Okay, great. Yeah, 5 is going to get printed. It's going to print the highest number between these two. And min kind of does the same, right? Like I don't need to repeat this again. You know what it does. It prints, min just prints the smaller number of the two. Okay, and cosine is just, so if you haven't learned trig yet, you shouldn't worry about this, but if you have learned trig already, then this just gives you the corresponding ratio of the sides. So cosine is adjacent over hypotenuse. So if you give it angle, then it's going to give you a number. So let's say cosine of system dot print line math dot get printed here. Hello, can you hear me now? Okay, it's back. So what do you think would get printed if you said math.cos 30? Well, cosine of 30 degrees is just 1/2. So it just gave you 1/2. Well, actually it didn't. I think the reason why is because it's asking for, is this asking for a radian or? Right. Cosine, sorry, sine of 30 is gonna give you 1/2. Yeah, this is probably in it's asking us to enter radian. So let's do math.pi over 6. Oh, there you go. So it's asking us to enter in radians. Yeah, like it gave me the same thing because what we did was we entered degrees, right? And it doesn't want degrees, it wants it in radians. So if you do math.pi is just pi over 6, that's 30 degrees. That's going to give us 50, 0.5. Not exactly, it's quite close to 0.5. You can just assume that it's 0.5. Or you can just, like, you don't need to worry about it. It's just 0.5. If you do a kind of like, yeah, it's just 0.5. Are there any capital letters in the word pi? You have to write math.pi, and both p and I have to be capitalized. Okay, yeah, so the cosine and the sine and tangent method, they kind of want us to write it in radians. They don't want degrees. Apparently, the people who made Java prefer radians. I don't know why, but that's just what it is. Okay, so sine, well, we were doing sine here. If we do cosine, then it's going to give us around 0.86. That's just pretty much the same as root 3 over 2. Okay, and over here, sine, same thing.
We can't hear you, Mr. Brian. Your mic is out.
Can you hear me now?
Yeah, we can hear you again.
Okay. All right. So sine and tangent, similar thing, right? Just going to give us a number based on the angle and radians that we give it. Okay, so 2 radians and 2 degrees. This is just converting from radians to degrees. System.out.primline. Let's say math dot or math dot 2 radians math dot pi. What is this going to give us? This is just giving us the degrees of the corresponding degrees for pi. And what is this for people who have already learned trig? It's going to give us 180. 180, okay, yeah. Let me take a look. 2 radians. Oh, sorry. Yeah, that's the 2 degrees method. This one, sorry, it's the other way around. So if we enter a 180, then that's going to give us pi, right? You can see here, let me move this. So 3.14, blah, blah, blah. So that's going to give us, pi. And if we do it the other way around, if we do the 2 degrees and we tried printing out math dot 2 degrees and then we gave it math dot pi. Now this is going to give us 180. Okay, so that's the past 5 methods have all been about trig, and the rest are going to be non-trig. So the floor method, that's just if you enter a number, it's going to floor that number. So it's always going to give you, if it's a decimal number, it's always going to floor it down. So math.floor 1.1. 1.1, what is it going to give you? This is going to give you 1. Give you 1. Even if you do 1.9, 1.99, it doesn't matter. It's always going to give you 1 because it always floors 1 down. If you do negative 1.2, what do you think would get printed? Well, since it always floors down, it's going to give you a -2. It's not going to give you a -1, but a -2 because -1 is greater than -1.2. So, okay, and then floor seal, opposite, this is just the opposite of floor. It gives you always rounds up. So if you do -1.2, this is going to give you -1. It's going to give you -1. See? Okay. And then let's talk about, so in order to know exp, you need to know math.e. So let's talk about e. Oh, accidentally, okay. So e is just, keeps typing in the chat. Okay. E is just Euler's number, which is equal to 2.7 something. And so right now you don't really need to know what it is. It prints the exact value of this number, which is, if you print it, it's 2.718 and more. Okay, so that's what E is. And then now we can talk about what exp is. Exp. What this is, it raises E to the however manyth power. So if you do math.exp and then do 1, like what do you think would get printed? It's going to print the same thing as e because it's e raised to the first power. It's going to give you e raised to the second power, and so on. So it just raises this e value to whatever power you want it to. Okay, and then log is just log, so system.out.println. Log is I don't remember exactly if they're using base 10 or base e, but if it's base e, then it's going to be ln. So let's just say let me see if oh really, okay, so let's see. So Java is actually going to print infinity in infinity. Oh, okay. Yeah, I think that's what it does. It's quite funny. So yeah, I don't remember exactly what the log does. So log method in Java. Log natural log base e. Oh, I see. So it's gonna return the base e log of the number. So yeah, I'm not gonna explain what log is if you haven't learned it yet, but for now you just have to know it's this is gonna return the base e log e. So this should give us 1.
We can't hear you.
Power is gonna give us e. So e to the first power. Okay, Mike is back. Okay, so what e does is it returns whatever power you have to raise e to get the number you enter here. So e to the first power equals e, so that's why it gives us 1. Okay, and I think these three are not quite important. Like I have never used them before, so usually I think if you're doing more math related tasks, you're going to use them a lot, but these are really not things that you need to remember. Okay, so pow, what pow does, it returns the power a raised to the bth power. System.out.println math.pow, and you give it, say, 3 to the 4th, and what is that going to give us? It's 3 raised to the 4th power, which is 81. I think. Yeah, it's 81. 81. So it's the first number raised to the second number's power. And then round is just depending on the fraction, it either rounds up or down. So math.round 5.1, it's going to give us 5. If we do 5.6, it's going to give us 6. And you have to remember the round always gives us an integer, because over here it didn't say 6.0, it said 6. So that means that it always gives us an integer value. Square root. So what the square root does, it just square roots things, like system.out.println math.square root, let's say 4. That would give us 2, because 2 times 2 equals 4. Okay, and we have already gone over e and pi. So that's all the methods that you need to know. And today I'm just explaining a little bit of what these methods do, and you're going to be able to find these methods on the slides, which you have access to. And you don't have to remember all of them. like I don't even have them remembered, all of them remembered. You just have to, when you know you need to use something, you can just search it up on Google and see what it does. Okay, but it's good to go over them so you understand how to use them overall. Okay, and so that's pretty much what we want to cover today. So we started at 9:30, and then it's been 40 minutes, and I want to see how many of you would like to. I was thinking of building a game because using Java, because we already learned pretty much everything that you need to build a game, and that would be really fun. So raise your hand if you if you know how to like use a raise hand function in Java. Raise your hand if you would like to build a game. Okay. Well, what about the rest of you? Are you like um do you prefer building a game or well uh oh, someone's saying no. Okay. Well, I think it's a good idea to practice building a game because I was thinking of doing a tic-tac-toe game using Java. I don't know if you guys have played tic-tac-toe. Well, everyone played tic-tac-toe, and uh, or have you guys tried building it in Java? So this is something I found on GitHub. It's like someone wrote this code to build the game, but obviously we're going to be building it from scratch.
Yeah, Mr. Brian, we can't hear you anymore.
Oh, can you hear me now?
Yes, we can.
Okay, great. Okay, so I think most of us have played tic-tac-toe already, but for those who haven't yet, I'm going to briefly explain how it works. So what it does is so how it works is let me draw a square. So usually they're played on a you play them on a square grid, and uh, inside of this square there's 9 boxes. So uh, okay, so there's 9 boxes, and then you're either X or you're O, and so there's 2 players. So player 1 could be X and player 2 could be O, and the goal is to create uh, like a continuous to create a line using your symbol. So like X is so if you have X, so all 3 here, then uh that means X would win, right? And then if you have O, O here, then O would win. And this works for all of the rows. So O would also win. And you could also have it on the 2 diagonals. So O, this would win. Or you could have X here, X here. My mic is okay. Okay, it's back. So let's say X picks the center position, and then O would try to block X by putting a O here. Now it's back. Now it's X chance again. So let's say X picks this position, and then let's just say O is extremely stupid. It forgot to block X here. So O, like for whatever reason, choose to put its next block here. So X goes here, and then X wins because it got one row. And let's say if O was smart and O decided to put its block here, and then X decided to block O to put its one here, and then O decided to block X, and then X put, well, actually, in order not for O to win, X has to put one here. And now it's impossible for anyone to win, but we're gonna continue until someone, well, X could still win, but O is gonna put their next one here, and then X is gonna put it here. So that would be a tie. So in order to win, you need to have either the entire row covered with your X's or O's, the entire column, or the two diagonals. So does that kind of explain the rules for the game? And we're gonna try to simulate and make this game in Java. So so it turns out, so if you have already done it, then you're gonna probably find it to be quite easy. But if you haven't done it, then it might be kind of hard for you. But so this is some sample code. This guy wrote around 122 lines, which is not too bad. So we're gonna try to do this. Okay. Right. So let's start a new project called Tic-Tac-Toe, and just call this Java Tic-Tac-Toe, and then finish. Don't create the module, and then create a class inside of the source folder, and we're gonna call this main class, and check the main method. Press finish. And today I just want to write all of our code inside of the main class because it's a relatively simple game. We don't need to use any additional methods. We do need to use additional methods, but we don't need to use additional classes. So the first thing that we probably want to do is to simulate the board. And in order to do that, we need to use a 2D array, so a two-dimensional array. And we talked about one-dimensional arrays, but we haven't talked about two-dimensional arrays. But it's pretty much the same. It's quite similar. To declare a two-dimensional array, so int, instead of one brackets, you put two brackets, and then give it a name. So board equals new int, and then give it the dimensions here. So the dimensions are 3 by 3 because that's our grid. So 3 rows and 3 columns. So that's how a 2D array works. And let's start adding elements to the array, to the 2 by 2 array using 2 for loops. For int I is equal to 0. So this is just board This is adding elements to the board. For int I is equal to 0, I is less than 3, I plus plus, or int j is equal to 0, j is less than 3, j plus plus, board I, j is equal to, we want to set the initial value to be like this. Actually, let me make my board a char board instead of int. And then let's make this a char. Okay, so now we have already added the elements to our board. And if we try printing the board, prints the board. So I'm going to run the same loop, but I'm going to print so that just prints it in a vertical line. In order for us to see what can you still hear me? Okay, Mike came back. Good. All right. Yeah, so you can hear me now? Okay. So now if you print this, it's going to give you this, but what we want to do is have spaces between our underlines. So let's add a space so we can see them more clearly. Right now you can see your grids. Okay. Usually you want to write as little as possible in your main method because so you can see it more clearly and understand it better. So you just want to create another method that basically prints the board. Print board that takes the input. So this takes a 2D array board, and it just static void, public static void print board, and then we're going to move all of our code in here. So this print board. Now, if we want to print the board instead of writing all the code again, we can just do print board and pass in the board. So board. Now it's going to give us the same thing. Okay. Right. So if you think about how we want the users to play this game, what we kind of want to do is to show this board first. So it's all empty. And then let's say X always starts off first. And we want the user to enter a number from
I have an error.
Is the mic still not working? Back. Okay. So what you want to do is show this empty board and then ask the user to enter whatever position they want to enter. They want to put their first X in. So for this, we're going to use a scanner. Let's declare a scanner. So scanner s equals new scanner system We need to import the scanner class. So that's just imported. Okay. And
Wait. Oh, can you scroll up? I think I for. Oh, never mind.
okay. So you need to create a new instance of the scanner called, I just called it S. And now we need to ask the user to enter a number. So system.out.println, please enter a number from 1 to 9. So now that the computer asks the user to enter a number, and we need to collect the number that the user entered. So int int position equals s dot, or let me declare this int up here, int position, and then set it to s dot next int. No, not, is it next int? Yeah, it's next int. And just to test whether or not this works successfully, we're just gonna print s here, and then let me try to see if this works. Please enter number from 1 to 9, and let's say we enter 1. Oh, sorry, not s. Why did I put s? Position. From 1 to 9, 1. Okay, it printed 1, so that works. Can you go up to the thing you imported? Yeah, so it's java.util.scanner, and you can just hover, if you haven't imported it, hover your mouse over this scanner, and it's gonna say import the scanner class, and when you hit and import, it automatically imports it. So the reason why, yeah, the reason why your lines are all in a straight line is when you printed it. So you use 2 for loops, right? You have to write a system.out.println under your the inner for loop, and that's gonna solve your problem. Okay. So so give us 1, but we didn't, our goal is not to make it print the 1.
Wait, excuse me. I haven't done the print board method yet.
Okay, so so like right now you can just follow, and I'm gonna so copy this entire project once we're finished, and then I'm gonna post it so you guys can see it afterwards. Or you can, like, if you want to type it now, then you can also do it now. But I want to like go over this really quickly, so because it takes a lot of time to build the entire project. Print board. So like,
I have a question.
yeah.
On line 22, why do you have a like a squiggly parenthesis?
This is for our main method.
Oh, okay.
Yeah, yeah. So, but we don't want to print this. We want to set the board. So if we enter 1, then we want to set row 1, column 1, or in Java, row 0, column 0 to X. So let's just do board 0, 0 equals X. And then let's print the board again. Board. Now that we have this, if we print the board again, so right now we're just assuming that the user entered 1, right? We're gonna have different cases later on, but so let's say 1, and it successfully put the X in that position. But if we entered 2, it's still gonna give us still going to put it in this position. So we want to write this so that let me think about this. Okay, we can make the user enter a number. Okay, so please enter a row number. Let me, instead of making this position, I'm going to change this to row. This to row equals s.nextInt and system.out.println. Please enter a column number. And column equals s.nextInt. Let me declare the column. Okay, so what we did was we're asking the user, instead of putting a number from 1 to 9, we're just asking them to enter a row number, which is 1 and 3, between 1 and 3, and then enter a column number, which is between 1 and 3.
Can you pause?
Oh, yeah. So, yeah, am I going a bit too fast? Okay. Yeah, sorry about that. Yeah, so really
Where do you create the column variable?
it's on the top. So I think instead of so it's more important to understand how the logic works, because you guys already learned how to write these things in Java. It's more important to understand how the logic works than type. Sometimes, like if you're trying to type everything, you're not really taking enough time to fully understand it. So I would recommend like just following along, and then I'm gonna post the code on online, so you guys can copy it and go through it again. So let me explain this again. So we created a board. It's a 3x3 board, and then we added this underline to every position. The underline just means that there's nothing currently in this position, because when we start the game, all the slots are empty. We're gonna represent that using an underline. And then when the game starts, the board is gonna first get printed. So we use our print board method. We call this print board method to print our board. That's why I printed this empty board here. And then we use a scanner to ask the user to enter a row number. So this is the X user. We're asking that user to enter a row for their first location. That's between 1 and 3. And then we collect that row, and we ask them to enter a column, and we collect that column. Right?
Can I write down the whole method yet first? I'm not done writing it down.
Oh, the print board? Okay. So, yeah. So you don't actually need another scanner. You just need to use one scanner to so you only need to create one scanner instance, and you can just keep using it. Let me type. Yeah.
Mr. Brian, your mic.
Oh yeah, I'm not talking right now.
Sorry.
It's fine. Just do you guys know, like, understand why? It's fairly simple. Right now we're just asking the user to enter a number and seeing what they enter and trying to add the corresponding X to the position.
I have 3 errors.
Okay. Yeah, you know, I think it's really hard to follow right now. So you can just uh like copy the code later on and run it to see how it works. But um yeah, okay. So basically the problem with our code right now is, see, if you run this and you enter 2, or if you enter 4, or sorry, let's say let me run this again. Okay, actually let me finish. So we're asking them to enter row number, and we're asking them to enter a column number, and then we're just gonna say board row and column. We're gonna set this to X. Yeah, so you can, I was thinking you can add a -1. That's a good idea, but so if we ask the user to enter number between 1 to 3, then we have to -1. But if we ask them to enter a number between 0 to 2, then we don't need to -1. But usually they enter between 1 and 3. So we're just going to use board column row equals X. Now this code should work perfectly. So ask us for a row number, and then we say 2. And then column number, we say 2. And then this should put the X right here. Right? Perfect. So put our X right in row 2, column 2. So that's pretty good. Now we need to find a way for us to repeat this. So let me run this. 3, 0, 1, 2, and then, so yeah. Yeah, Jason is absolutely right. I think column does go first. So meaning that we need to swap these two, because if you're doing row 3, column 2, then this is supposed to be 1, 2, 3, and then 2. So that's supposed to put it right here, but it put it at row 2, column 3 instead. So if we run this now, then we put 3 and then 2, then that would give us the right position. Right, so that's exactly what we need to do. So we need a while loop. We need to use a while loop to keep repeating it until someone wins. But to find out whether or not someone wins is a relatively complicated process. We need a different method, and we need to do a lot of extra work. And for now, we're just gonna allow the user to keep entering for 9 times, because there's a total of 9 grids. So we're gonna let them keep playing. We're gonna use a for loop, and we're gonna let them let the code keep running until all of the 9 slots are filled.
I got 6 errors when I tried running it, and I don't know why.
Oh, it's fine. Just follow along. Like,
Okay.
as I said, it's really hard to like type while you try to understand everything.
Okay.
So yeah, I'm gonna post it anyways. Yeah.
Okay.
So right now, so this section of code we want to repeat 9 times. So let's do a for loop for int I equals 0, I is less than 9, I plus plus, and let's repeat this code 9 times. And that should, once we add this inside a for loop, that should allow us to keep doing it until the grid is full. So let's say 1, 1, or 1. Yeah, I'm gonna change it to a O later on. So okay, so and then 1. I didn't copy and paste. I put everything inside of a for loop. So this is gonna run for 9 times. Yeah. Okay, 1 1, and then let's do 1 2, and then let me move this up a bit. 1 3. Okay. 2 1. 2 2. 2 3. Okay. And then now let's do 3 1. 3 2. 3 3. Okay, so we entered all of our elements. But one problem that you guys already noticed is it was all X. So it's actually very easy to fix this problem. Instead of putting this as an X, we're going to change this to a variable called turn. And at the top, we're going to do turn is going to be a Boolean. So turn is equal to true. Whenever turn is equal to true, it's X turn, and whenever it's equal to false, it's going to be O's turn. So we're going to write if turn is equal to true, we're going to write board column row is equal to X, else board column row is equal to O. But we also need to switch it every time someone enters, because after X enters, it's O's turn. So we need to change it to false. So turn is equal to false. And if it's false, then we need to turn it to true. Turn is equal to true. Okay, so now once we have this code, if we run it again, so 1 1. Now if we enter 1 2, that's going to give us a O, and 1 3, it's going to give us a X again. 1 4, that should give us an error, because you cannot type a number that's more than 3, because there's only three rows and 3 columns. Okay, so yeah, so that works. Yeah, that works. Okay, so the next thing that we need to write is to find out whether or not the winner, to find out whether or not someone has already won. And let me think about how we can do that. Wow.
Your mic.
Yeah, so trying to think. I think we can what we can do is to, but when I do it, it prints the board twice. I think what we can do is to create a method so it checks at every stage whether or not someone has already won. So method that checks if someone has already won. Public Boolean public Boolean public Boolean game state, and this is gonna take in a board. Right. Okay. So this public bool. Okay, so it's asking asking us for a return statement. We're gonna put that in later. Right now, let's just return true. Okay, what this does is it returns whether or not someone has already won. So right now, this method doesn't do anything yet, and that's why we're gonna write some code in here. So what we're gonna do is check if someone has already won. So the first case that someone has already won is they have an entire row. So row 1. So let's say if board 0, 0 equals board 0. So it's the first 0, 0, so 0, 1 equals board 0, 2. And return true. So basically what this does is it checks if the first row, so if the position 0, 0 is equal to the position 0, 1, which is equal to the position 0, 2. And if it is, then someone has already won. So we're going to return true. And then the second case is just the same thing, but row 1, column 0, row 1, column 1, and row 1, column 0 equals row 1, column 2. That would also return true. And then it also works for row 2. Okay, so this pretty much checks the whether or not someone has won using rows. And since we're writing this 3 times and it's kind of repetitive, we can just use a for loop. So for int I is equal to 0, I is less than 3, I plus plus. And then let's do this. Instead of putting 0 here, we're going to do I. So then we don't need the rest. So this is just saying, so at the end, if none of them are true, we're going to return false. So this is just checking to see if there's someone who has already won by having an entire row. And the other way that someone can win is by having an entire column. So we're going to use the same thing. We're going to do the same thing that we did here, but we're going to say this is 1 or 0 is equal to 1, 0 is equal to 2, but we're going to do all 3 columns. So we're going to replace the column with I. Okay, so that's going to return true. And the final way that someone can win is by having the diagonals. So third case, the 2 diagonals. Okay, and we don't need to generalize this because there's only 2 cases, and it's much harder to generalize diagonals than it is for rows and columns. So we're just going to use if statements to check if board 0, 0 equals board 1, 1, and board 0, 0 equals board 2, 2. Then we're going to return true. This is a third condition, and then the final one is just board, and this is the other diagonal, so that would be the other diagonal would be 2, or was it 0, or if the column goes first, then 0 and then 2 equals board 1, 1, board 0, 2 equals board 2, 1. Is that right? So 2, 1 is column 2, 2, 0. So 0, 2, and then 0, 2, and then 1, 1, and then 2, 1. Yeah, that's right. So, and in this case, it's also going to be true. So now we consider all the possibilities that it could be true. And at every stage, we're just going to say, we're going to keep running it until someone wins. So instead of writing a for loop here, we're going to do a while game state is equal while game state is equal to true. We're going to keep running this. Okay, and once it's not true, we exit out of the while loop and we're going to say game over. So right now we're going to say game over, but later on we're going to specify whether it's a tie, whether X1 or O1. So game state, right? And game state, we need to enter a board. So we're going to put the board here. Why is it still complaining? Private static. Because we're accessing it from a static method, we need to make this also static. Okay, so now let's say we have 1, 1, and then X is at 1, 1, and then let's say O is at 1, 2, and then let's say X is at 2, 2, and then O is at 1, 3, and then finally let's make X win by putting in 3, 3. Right, okay. So while game state board is equal to true. If any of these conditions are met, then we need to return false to stop it from working. So otherwise return true. Okay, so now it should work. Let's run this again. Okay, and oh, okay. Right, okay. So one condition that we haven't checked yet is, so, okay, let's just, because it could also, the reason why it gave us game over is because all of these conditions were true, because these three elements are the same. So one thing that we still need to check is they are the same, but they also can't be this underline. They have to be an actual character. So if board, let's just add this individually. If board I 0 I 0 equals underline, or does not equal to underline. And okay, now let's add this to board 0 I does not equal if this does not equal if board 0 does not equal, and then finally 0 2 does not equal to underline, and this is true, then we're gonna make it false. Let's run this again. Oh, board. Okay, there we go. Okay, hopefully it works this time. Let's say we want to make x win, so x is 1 1, and then y is 1 2, and then x is 2 2, and then y is 3 2, and then finally let's make x win by making x 3 3. Game over. Perfect. So we have x in diagonal, so the game was over. And let's see, we have 3 more minutes to complete the game. The last thing that we want to do is not just give us game over every time, but actually make it tell us which player won or did the game tie. Right, so let's say, so when turn is equal to true, it should be when turn is equal to, so if at this move the game is over and x was the last one, then and turn is equal to true, then okay, so if turn is equal to true, then we know that the winner is x. Else turn is equal to true, then we're going to print x1. Else we're going to print system.out. Else if out.println, let's say 01. Okay, let's run this again. 1 1, and then 1 2, and then 2 2, and 1 3, and then 3 3. X1. Perfect, because 01. Okay. Let's make this the other way around then. Because I guess what happened was when X won, then the next turn is O, so it switches to O before we check this statement. So 1 1, 2 1, 2 2, 3 2, 3 3. Okay, X1. Perfect. Now let's see if we want to make O win, then that's 2 3, and then 1 1, and then 2 1, and then 2 2, 1, and let's make O win by doing 3 3. 01. Perfect. And we have built our tic-tac-toe game. And this game is for the way that we designed this is, and we only wrote it in 77 lines of code, which is less than the one that we saw. And this game is designed for people to play, for two players to play together. It's not designed for a player to play with a computer. And that's actually not as hard as you may think, because if you want to make one player play with a computer, then you just need to generate a random number for the position of the row every time, and then make the player enter a number, and then make the computer select a number, and then see if the player or computer wins. But this is the most basic version of tic-tac-toe, and I'm gonna paste this onto Ed after class. So if you need to look at it more and think about how it works, then it's gonna be there for you. So is there any other questions? If not, then well, I'm just gonna wait to see if there's any other questions first. Okay, so if there's no other questions, then I'm gonna end the class here, and thank you so much for coming to class. I hope you guys had fun making a game and learned a lot. And I'll see you next Tuesday. We're gonna talk about thank you. Next Tuesday we're gonna talk about like inheritance and more complicated stuff with classes, polymorphism, and that's gonna be our last lesson. And on Wednesday and Friday, we're going to do some practice and have a competition. So that's our plan. Okay, thank you so much. Have a good weekend.